Now you know everything about variables. Well, almost everything. In fact, it's a composition of 3 elements: name, value, and type. Referring to the concept of a dresser, a drawer has a name, the label, the space to put the value inside. But what kind of value? A pair of socks, a pair of pants, or maybe a coat? Why is this important? First, to choose the size of a drawer. Or we may not have an item just yet, but knowing that we're going to use it for socks will help us reserve the most suitable one. Another important aspect is to define functional context around it. If our feet are cold, we're going to look for socks and not for coat, for example. Speaking of variables, there is a set of functionality applicable to numbers. We can multiply or divide them, but not the text, for example. In this chapter, we're going to learn 3 numeric types and a string type. The numeric types are integer, to work with whole numbers, float, to work with decimal numbers, and double, to work with decimal numbers. Wait, did I just repeat the same purpose twice? I did. However, there is a difference. Double, as the name suggests, can accommodate 2 times more precise numbers than float. Like mentioned before, we can apply basic mathematical operators to numbers, like addition, subtraction, multiplication, and division. And depending on the variable type we use, those operators will produce different results. Next comes string type. It's to work with text. It could be, "Hi Jenny," or we can write the whole poem in there. A useful operation we can do with strings is concatenation. Yep, we can merge the strings together. It could be, "Hi, I'm Olga. I love cats." To concatenate the strings, we use a plus sign, just like for the numeric addition. We can also insert other types of data when composing a string. Let's see how we can do this and the rest of what we just talked about in the code.
We now understand the essence of a variable, which is assigning a name to a value. Remember our code when we tried to divide 3 by 2? We had 2 variations of this calculation that produced different results. In the first scenario, it resulted into 1. And the second one produced 1.5. So what's the matter? The difference is the type of the values that we use in our calculation. Our first example is using whole numbers, and the second one has 1 decimal. Therefore, the whole result is interpreted as a decimal result. Numbers in Swift can be of 3 types: integer, float, and double. To describe those types, we use keywords int, float, and double. Int is used to describe whole numbers. Float and double are used to describe decimal numbers. The difference between float and double is precision. As you can probably guess, double is 2 times more precise than float. When declaring a variable, we can also specify its type by explicitly stating it in its declaration. For example, we can have variable height type float and the value 180.5. Now that we know how to declare a variable with a specific type, let's clarify the difference between float and double. If we declare 2 variables with the same value but different type, we can observe different results on the output panel. As you can see, the first one is declared as double and can hold a much more precise result than the second one that is declared as float. As we remember, we can also declare a variable without specifically stating its type, but just through assigning a value to it. In this case, we can observe that the result is exactly the same as if we declared it as double. In Swift, if the decimal numbers do not have an explicit type assigned to it, I interpret it as double by default. Let's remove our experimental code and go back to our SmartBean project. As we can clearly see now that we're dividing 1499 by 10 and getting the result of 149. So we're missing 0.9. That is because our variables are considered integers, and calculation is done using whole numbers. Let's correct this and explicitly state that our price variable is double. Before we move on to resolve the error that just popped up, let's see an alternative declaration to this. Let's comment this out for now. And instead of explicitly stating that it's double, we could assign it a decimal value. Okay, let's resolve the error we have in here. We are told that we cannot complete this operation because we have two variables of different type. One is integer, which is daily allowance is still 10, and the other one is decimal. To correct that, we need both variables be of the same type. We can achieve that by assigning the daily allowance value 10.0 instead of 10. Now, remember when we wrote 3 divided by 2.0, we didn't get any errors, even though 3 appears to be a whole number, integer, and 2.0 a decimal, which is double. This occurs because Swift interprets type of variables at the time of their declaration, so that our daily allowance was established as integer prior we tried to calculate the saving days. On the other hand, when we type simply numbers in the code, they are not assigned type ahead of time. They get interpreted at the time of calculation. In our example, at the time of calculation, there are two numbers needed, 2.0 and 3. Since one of them is double, the other one is getting interpreted as double on a spot. Therefore, the division is done with two double numbers, and everything works fine. The next variable type we're going to learn is string. Let's delete this code for now. A string is simply text surrounded by quotation marks. I'm a string. We can declare a variable of string type by simply assigning this value to a variable. And now we know we can also explicitly specify the type of a variable, string in this case. And what can we do with the strings? We can concatenate them, join pieces of string together in one. And we can observe on the output panel that our initial string components appear as one. Concatenation is done simply by using plus sign, just like for mathematical addition. We can also insert other types of values into our string. For example, if I eat 2 meals a day, I can compose a string stating so. And we observe in the output, it says I eat 2 meals a day. To insert values of different type in a string, we simply use / and place that value in brackets. Now pause this video and try to create a string that will communicate the results of our calculation to Jenny in a nice way. Welcome back. Here's my version. Hope yours looks very similar.